Good morning, students. So today in this extra class, we're going to be finishing our first chapter, okay? So we're going to be starting with a new topic, which is dealing with exponents, okay? We're going to study laws of exponents and how we're going to apply those laws on questions, okay? And before starting, we need to know what are exponents. So look at this, a cube. Now, a is a variable. Variable means what? Variable, right? Variable means that can vary, that can change, right? Which means whatever value I put for 1, according to that, the value of this expression will change. So this is called a variable. A is called a variable. It can take varying values or changing values, right? So look at this variable. This variable has a number which is raised to it, right? Raised to means on top, right? So you can see this number. So this is called the exponent of this variable, okay? So whenever you see x square, x cube, x raised to 1 by 2, x raised to 3 by 4, etc., you know that those 1, 2, 3, 1 by 2, minus 1 by 2, etc. are called the exponents of that variable, okay? So this is what exponent is. Now keeping in mind what exponent is, let's go on into the main part of the topic, okay? Now, before starting the laws, you need to know some things, some basic things. Let me explain. Look, root a. Now, if you want to remove the root, if you do not want to write the root, instead you can write a raised to 1 by 2. Now, a raised to 1 by 2 means, where is this 1 by 2 written? Look at it carefully. A raised to 1 by 2. It's written on top, right? It's not written below. It's not written like this. If it's like this, it's wrong. This is wrong, okay? This is wrong. This is the right way of writing it, okay? A raised to 1 by 2. So a should be on top. A should be 1 by 2 should be on top. 1 by 2 should be the exponent of a, right? So we can express root a as a raised to 1 by 2, okay? This 1 by 2 signifies that a is inside a root, okay? Now likewise, cube root of a can be written as a raised to 1 by 3. So for the rest of the numbers, you will be familiar with it, right? Fourth root of a, how do we write? A raised to 1 by 4. Fifth root of a, how will we write? A raised to 1 by 5. Sixth root of a, how will we write? A raised to 1 by 6. So that means 1 by something means what? That it is inside that number's root, right? It is inside that number's root. So a raised to 1 by 2 means it is inside the second root, right? A raised to 1 by 3 means it's inside the third root. And a raised to 1 by 4 means it's inside the fourth root. So likewise, a is inside a root means a raised to 1 by 2. A is inside a cube root means a raised to 1 by 3. A is inside a fourth root means a raised to 1 by 4. So that means square root can be shown by this way also. Cube root can be shown by this way also. And any root can be shown by this way also. So if I generalize it, I can write nth root of a is equal to what? Is equal to a raised to 1 by n. I can write it like this, right? So this is what generalizing is, right? So for any number, this is true. This is applicable for any number, right? So let us see some more other basics. Now look, now 1 by a. Now look at this expression 1 by a. In order to show that a is in the denominator, I can write the same number as a raised to minus 1. So when you see a raised to minus 1, you have to automatically know that a is in the denominator and 1 is in the numerator. Okay, so this is what you have to know as soon as you see a raised to minus 1. A raised to minus 1 means what? 1 by a means a is in the denominator. What is the denominator and numerator? This is the numerator, the upside number, right? And this is the denominator, the number below, right? So 1 by a is equal to a raised to minus 1. So a raised to minus 1, whenever you see, you have to know that it is 1 by a. That means whatever variable you have been given here, a, x, 2, 3, whatever you have been given here, that will be below 1 and it will be in the denominator, right? So that is what you need to know from this expression, okay? Now, next, just like a raised to minus 1 itself, we can take a raised to minus 2. Now, what will that mean? It will mean that a square is in the denominator. Now, look, 1 by a square can be written as a raised to minus 2, right? So, like that itself, 1 by a raised to 3 can be written as a raised to minus 3. What does this minus sign show? Minus sign shows that whatever this is going to be below 1. That is, it's going to be in the denominator, right? So that is what it shows. So 1 by a raised to 4 is what? A raised to minus 4. So can I generalize this? I can generalize it and I can write 1 by a raised to n is equal to 1 by a raised to n is equal to a raised to minus n. I can write it like this, right? A raised to minus n. 1 by a raised to n is a raised to minus n, right? So this is how we generalize it. This is what you have to remember, okay? Now the next thing. Now look here. 2 raised to 2 by 3. So 2 raised to 2 by 3. Can I write this 2 by 3 as 2 into 1 by 3? Yes, I can write it, right? So let me show it to you once. 2 by 3. 2 by 3, I can write it as 2 into 1 by 3, right? Why? Because 2 into 1 is what? 2. And 3 into 1 is what? 3. There's one invisible 1 here, right? So 3 into 1 is 3. 2 into 1 is 2, right? So therefore I can write 2 by 3 as 2 into 1 by 3. So that is what I did here. First a raised to 2 by 3, I split it and I wrote a raised to 2 into 1 by 3, right? Now look here. Now I have already studied that this means what? This means 1 by 3. Anything raised to 1 by 3 means what? It is inside the cube root. We studied in the first part of this video, right? So if you did not understand this part, please stop here and please rewind it and please watch that part, okay? So a raised to 1 by 3, we have studied what? We have studied that a raised to 1 by 3, just in this previous part of this video, just 5 minutes ago, we studied a raised to 1 by 3 means that a is inside a cube root. A is inside a cube root, right? So like that itself, now a square is raised to 1 by 3. So what will be inside the cube root? A square will be inside the cube root, right? A square will be inside the cube root. So that is what we did here. So first a raised to 2 by 3. As soon as I saw 2 by 3, I first split it into a raised to 2 into 1 by 3 because I know that 1 by 3 means cube root. So a raised to 1, a square raised to 1 by 3 can be expressed as cube root of a square. Why? Because whatever it is with 1 by 3, that is inside a cube root, right? So a raised to 2 by 3 can be written as what? A raised to 2 by 3 can be written as cube root of a square, right? Cube root of a square. So now let's see the next one. So here I've brought it close. Look at it carefully. A raised to 2 by 3 means a square raised to 1 by 3. Why? Because 2 into 1 by 3, right? So 2 into 1 by 3. So I can express this as a square raised to 1 by 3 also. So a square will be inside the cube root. Why? Because 1 by 3 shows that whatever this is inside a cube root, right? Now next. Now look at this. I combined everything that we studied until now. A raised to minus 2 by 3. So a raised to minus 2 by 3 means what? A raised to 2 by 3 means what? This square shows that, this 2 shows that a has a square, right? This 3 shows that a square is inside a cube root, right? And this minus, what does it show? Minus shows that whatever this is going to be in the denominator, right? So what did I write? Cube root of a square is in the denominator. So 1 by cube root of a square. So a raised to minus 2 by 3 means 1 by cube root of a square. So whatever we studied until now, we applied all of that on this number, right? Now look at this, a raised to minus 1 by 4. How do I write? A raised to minus 1 by 4 means this 1 shows that a has raised to 1. So a will be a itself. Now 4 shows that, 4 below shows that it will be inside a fourth root, right? So it's inside a fourth root. Now minus shows that it will be below 1 in the denominator. So 1 by fourth root of a, right? Now the next one. Now look at it carefully. This 2 shows that exponent of the variable. What is this 2? What is this? Any number that is represented here will be the exponent of the variable. What is the exponent? A raised to. So exponent means if I write a raised to 5, what is the exponent of a? 5 is the exponent. So whatever number I represent here, it shows the exponent of a. So here what will be the exponent? Here it will be 2. So it will be a square, right? Here it will be a square. Now the next one. Next one is this type of root. Now 3 shows the type of root. Whatever number is below in the denominator shows the type of root. So here what root is it going to be? It's going to be cube root. So cube root of a square, right? And what does this minus indicate? This minus indicates numerator or denominator, which means here if it's plus, whatever this expression is going to be in the numerator. Here if it's minus, then this entire thing, this expression is going to be in the denominator. So 1 by cube root of a square. Look, first we looked at the first number, we formed a square. Then we brought it inside a cube root because it's below is 3. Then it's minus, so that's why this entire thing we brought it below in the denominator, right? So this is a very, very important expression. Okay, please take a screenshot of this page, or please pause it and write it down in your book, because I've broken it down in the most easiest of ways I can for you. Okay, so please make sure that you have remembered this, because it's very, very important, the next part of this chapter. Okay, now the next one. Now we are going to get into the main part of the chapter, which is laws of exponents. We're going to study the laws and we're going to see how we apply these laws. Okay, so first law is a raised to m into a raised to n is equal to a raised to m plus n. So look here, a raised to m into a raised to n equal to a raised to m plus n. What does this mean? Look here, let me show you some examples. If you see the same number, okay, the same number AA, can you see that? If you see the same number, but it's raised to different numbers. It's raised to different numbers means what? The exponents are different. M and N, look here, the exponents are different, but the numbers are the same, right? A and A are the same and exponents are different and they are multiplied. Multiplication, can you see any plus or minus here? No. So it's multiplied, right? So a square into a cube. So you can see that the same numbers with different exponents are multiplied. Then how can you solve it? You don't have to individually solve it and then multiply it. Instead, what can you do? You can take a as common and you can just add the exponents. So 2 plus 3. Can you see? A, so A. And 2, 3, so 2 plus 3. So 2 plus 3 is 5. So a raised to 2 into a raised to 3 can also be written as a raised to 5, okay, using this formula. So now let's see, using that on numbers, how do we use it on numbers? Look here, 3 raised to 4, 3 raised to 7. Now if I find 3 raised to 4, it will be a very huge number. 3 raised to 7 will be another huge number, and if we multiply them, we'll get another big number, right? So instead of that, what can I do? I can just use this formula, 3, 3, so 3. 4 plus 7, 11, right? So I get 3 raised to 11. So directly I can just find 3 raised to 11, right? So that is how we use this formula, okay? So this is the first law of exponent, right? So exponents can be added when the two numbers are multiplied are same, right? When the two numbers below are the same and they are multiplied and exponents are different, then the exponents can be added, okay? Now, again, this one, even if it's not numbers, even if it's variables also, it's applicable. So 2 raised to x, 2 raised to y. So you can see 2 and 2 are the same, but the exponents x and y are different. So 2 raised to x plus y, right? Now the next one. So the next formula is a raised to m, the whole raised to n is equal to a raised to mn. So sometimes you see a squared, the whole raised to 3, or a raised to 3, the whole raised to 1 by 2, or etc., right? So what should you do that time? When you see 2 raised 2's or 2 exponents, what do? You multiply those exponents. So a raised to m into n. So you multiply those exponents, right? So this is what the second rule is, okay? So let's see how they have applied this rule on the question. A raised to 4, the whole raised to 3. So 4 into 3 in the next step using the formula. So 4 into 3, 12. So a raised to 12, right? Now 2 raised to m, the whole raised to n can be written as 2 raised to m into n, right? So likewise, look, all numbers, 4 square, the whole raised to 3. So instead of finding out 4 square and then finding out the cube of it, what do? 4 raised to 2 into 3. 2 into 3 is 6, so 4 raised to 6, right? So this is how we find out questions using this formula, okay? Now all these formulas need to be by heart, need to be properly thorough inside your mind, only then you'll be able to do the questions in your exams, okay? Now the next one is this, a raised to m divided by a raised to n is equal to a raised to m minus n. So when you see the same number but with different exponents. Can you see AA and M and N? So same numbers with different exponent. What do? You write the number and you subtract the exponents, right? So you write the number first and then you subtract the exponents. So A raised to M minus N, right? Next one, you can see the example, A raised to 4 divided by A raised to 5. So it's same number, AA, but different exponents, 4, 5. So A raised to 4 minus 5 and equal to A raised to minus 1, because 4 minus 5 is minus 1. So A raised to minus 1, can you tell me what A raised to minus 1 is? We've just studied previously. A raised to minus 1 is 1 by A, right? So that means A raised to 4 divided by A raised to 5 is actually 1 by A. So from here you can even do it directly. So look here, A raised to 4, A raised to 5. So here there is 4 and there is 5 here. So what is there? 1 extra is there. So when this cancels and this cancels, 1 extra will remain, right? So you can even do like that also, or you can use this formula and do it, okay? So look at this example now. A raised to M, the whole raised to A raised to M divided by A raised to N. So you can see that it's the same number. Again, exponents are different. So what do you write? 2 raised to M minus N, right? Now the next one again, 2 raised to 12 divided by 2 raised to 8. So you can see it's the same number, different exponents. So what do? You write the number and then you subtract the exponents. 12 minus 8 is 4, right? So 2 raised to 4, okay? Now the next one, A raised to M, B raised to M is equal to AB raised to M. This is the third formula. Look at the formula. A raised to M, B raised to M is equal to AB raised to M. So you can see that all these formulas, we had this different exponents and the same numbers, right? But here what is the difference? Different numbers A and B and the same exponents M, right? So what do? When the different numbers with same exponents come, you can just multiply the numbers and put a common exponent. So A raised to M, B raised to M is equal to AB raised to M, okay? Now 2 raised to M, 3 raised to M can be written as examples. All these are examples. So let's see, 2 raised to M, 3 raised to M can be written as 2 into 3 raised to M, that is 6 raised to M. So 2 raised to M and 3 raised to M is equal to 6 raised to M, right? Now A square, B square is equal to AB square. 3 square, 4 square is equal to 3 into 4 square. So 3 into 4 is 12. So 12 square, right? So this is what you have to do, okay? Now the next one. A is any number. Then A raised to 0 is 1. You have to know this, okay? This is a rule. Any number raised to 0 is 1, okay? Any number raised to 0 is 1. You have to remember that. So A raised to 0 is 1. 1 raised to 0 is 1. 2 raised to 0 is 1. 3 raised to 0 is 1. Likewise, any number 4, 5, 6, 7, 100, 1 lakh. Any number raised to 0 is 1. Okay, so you have to remember this rule. Now the next one. So based on all these rules, we're going to do our last exercise of this chapter. Okay, this is one of the easiest exercises. And after this chapter, we'll be starting with a fresh chapter. So please make sure that you've learned all the things that we have studied up until now. Okay. Now, at the end of this video, I'll be telling you some very important points. So please note those points down as well. Okay. So now let's see exercise 1.6, question number 1. So first question is, we have 64 raised to 1 by 2 and we have to find the value of this. So we know that whenever we see 1 raised to 1 by 2, we know that whatever number this is supposed to be inside a square root, right? Because what did we study? A raised to 1 by 2 is what? Square root of A, right? Because this 2 signifies that it's going to be inside a square root. So like that, 64 raised to 1 by 2 will be inside what? Square root of 64. So square root of 64, we know that. 64, now how do we find out 64? What do? I factorize it. How do I factorize it? I take the number 8. 8 8s are 64. And since I'm finding out square root, I can take this 2 8 as 1 8, one single unit 8, right? So therefore, factorizing and all, you need to know all these, okay? Factorization, finding out roots, you're in class 9, so these were all done in your small classes, so you should know all these, right? So anyway, root 64, definitely it is 64 can be written as 8 square, right? So root 8 square. Now square root and square cancels and we are left with 8. So 8 is our answer, right? So that is how we do. Now let's look at the next one. 32 raised to 1 by 5. How do I do? First of all, since it's raised to 1 by 5, I know that it's going to be inside a fifth root, right? So 32 is put inside a fifth root since it's raised to 1 by 5. So fifth root. Then after that 32. I need to find fifth root of 32. So how do I find fifth root? 32, I'll factorize it. So 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. So when I get 1, I stop it. So this is factorization, right? So you have learned this in your younger classes, factorization. So if you do not know, please Google it or please search it or please ask it from someone you know or please approach me itself and I'll explain it to you, okay? Factorization is done in your small classes, so you should know all these things, right? So anyway, you factorize it. After factorizing, what are you going to find out? You're going to find out the fifth root. Can you see it? You're going to find out the fifth root. Look at me circling fifth root. So what do? Whatever number you get, you have to group it as 5, 5, 5 each, right? So here let's see 2. First number is 2. So let me see whether there are 5 2s or not. 1, 2, 3, 4, 5. So there is 5, right? So can I write this 2 as 2 raised to 5? 2 raised to 5 means what? 2 raised to 5 means 2 5 times, right? 1 2 3 4 5 5 times, 2 5 times, so 2 raised to 5. So 32 can be written as 2 raised to 5. So now 5 and raised to 5 and fifth root cancels itself and 2 is left. So 2 is our answer, right? So that is how we find out the answer, okay? When you find out fifth root, you have to group it into 5. When you find out sixth root, you have to group it into 6. So likewise, you have to group it and you have to find it, right? So 32 can be written as 2 raised to 5. Why 2 raised to 5? Because 2 5 times taken, you will get 32. 2 into 2, 6. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 2, 32. So you get 2 raised to 5 is 32. So that's why you write 5 square and 5 raised to 5 and fifth root cancels itself and you get 2 as your answer, right? Next question. Now next one, third part is a homework. Before that, I want to make this clear to you. Look here, this concept, this is a concept that we used in the previous question. So if you are not clear with that concept, then I just want to make it clear for you. So look at this carefully. Root 114. So what do I do with 114? First of all, I have to write, in order to remove the root, what do? Okay, that's what I'm showing you. Look, 144, you first of all factorize it. How do you factorize it? You take the least number, right? So what is the least number that I can take here? I can take 2 here. So I take 2. 2 7s are 14. Then 2 2s are 4, right? Now next is 2 again. 2 3s are 6. Then 2 6 are 12 because 1 is carry, right? So likewise 2 16s are. So etc etc. How many times will I get 2? I'll get 2 a lot of times. And when I multiply these 2's, what will I get? I'll get 12 and 12. So I can write this 144 as 12 into 12, right? 144 can be written as 12 into 12 because why? 12 into 12 is what? 12 into 12 is, when you do it, you will get 144, okay? So that's why 144 can be written as 12 into 12. Now why did I take 12 2 times? Because square root, I'm finding a square root, right? So I need any number here but 2 times. So 12 into 12, 144, so square root, therefore I can cut the square and the root will be cancelled and I can write 12 as my answer, okay? So that is why root 144 is 12. Now if you're not clear with this concept, please ask me, okay? Now the next one, cube root of 64. Now look, 64, I need to find out 64's cube root. So what do? I take a number such that I get 64 3 times. When I multiply that number, I get 64, right? So 64 is the number that I need. So what do? I factorize it. I can take 4. So 4 16s are 64. Then again 4 4s are 16. So I can see that 4 is the number that I got, and 4 I have to group it as 3. So I can write this as 4 cube, right? 4 cube. So 64 is 4 cube. Why? 4 into 4 is 16. 16 into 4 is 64. So 4 cube. So this cube and this cube root will cancel itself. So there is 4 cube inside this. So cube and cube root will cancel itself. So I can write one single 4 in place of that, right? So I write one single 4. So that means cube root of 64 is 4, right? Now the next one, again same example. Look here, 81, fourth root of 81. So what do I do? 81, I factorize 81. 81. So I factorize it using 3. So 3 27s are, then 3 9s are, right? Then 3 3s are, right? So you can see 3 4 times, 1 2 3 4. So fourth root, I'm finding out the fourth root. So I need 3 4 times. So 1 2 3 4. So look here, 3 3s are 9, 9 3s are 27, 27 3s are 81. So that's why I can write this as 3 raised to 4. So 4 and fourth root will cancel and I get 3 here, right? I get 3 here, right? So that is how I got 3 for fourth root. So likewise, I've given you these other examples also. Please look at it carefully. Look at this carefully because you'll understand the concept once you look at this. So this is the concept of root, alright? So make sure that you have understood this part properly, okay? Now the next part. Next question. Question number 2, part 1. 9 raised to 3 by 2. I need to find the value of 9 raised to 3 by 2. Now, whenever I see 9 raised to 3 by 2, what do I look? First, I look at the top number. What does the top number signify? Top number signifies that it's going to be 9 cube, right? And what does the bottom number signify? Bottom number signifies that it's going to be inside a square root, right? And what does the plus or minus sign here? What sign is it? Plus sign. So whatever sign it is, it signifies that it's going to be in the numerator or in the denominator. So here plus sign, so it's going to be in the numerator, right? So therefore I wrote this. Look, square root of 9 cube. Now even if I don't put 2 here, no problem, because I can understand that this is square root, right? So square root of 9 cube. How did square root of 9 cube come? From this, right? Like I explained right now. So square root of 9 cube. Now 9 cube I have to find. So what is 9 cube? 729. 9 into 9, 9 into 9, 81. 81 into 9, 729. So 729, right? So 729 root is 27. Why? Because 27 into 27 is how much? 27 into 27 is 729. Okay, so that's why 729, square root of 729 is 27, right? Now the same question, you can do it in some other way also. Look here. You can write this cube for the whole square also. Okay, it's not necessary that you have to put the cube inside. You can first take the square root of 9 and then you can cube that also. So here, this one can be written in two ways. Which way? First you can write square root of 9 cube also, or you can write square root of 9 the whole cube also. So what is the difference? Difference is here first you find 9 cube and then you take the square root, but here you will take square root first and then you will take the cube of it. So let's see, square root of 9 is 3. So square root of 9 is what? 3. Now 3 the whole raised to 3 cube. So 3 cube is 27. So you can see that the answers are the same, right? So you can do it in that manner also. Now the next one. Now look at this number. This is 32 raised to 2 by 5. So this 2 shows that 32 is going to have a square, and this 5 shows that 32 square is going to be inside a fifth root, right? So fifth root of 32 square. Now 32 square is 1024. So I write 1024, right? Now 1024 fifth root. So I have to factorize it. So I first factorize 1024. 1024. So I take 4 or 2 or any number you want, you can take. If you take 2, it's going to be a little longer. If you take 4, it's going to be a little shorter, right? So we need 4 how many times? We need 4 5 times because it's fifth root, right? So let's try. 4 2s are 8. 2 carry. 4 5s are 20. 2 carry again. 4 6 are 24. Then we have 4 6 are 24. 1 carry. 4 4s are 16. So 4 16s are 64. Again 4 4s are 16. So you can see 1 2 3 4 5. So 4 5 times, right? So I can write this 1024 as 4 raised to 5. 4 raised to 5, fifth root of 4 raised to 5, because 4 raised to 5 is 1024. I got it from the factorization right now, right? So fifth root and 5 cancels itself. Fifth root and 5 cancels itself, and 4 is our answer. So 4 is our answer. Or you can do it in this manner also. I think this is much more easier if you use this method, okay? But whichever way you want, you can use that. Instead of putting square along with 32, I put square as a whole, right? And because it will give you the same answer, okay? Square as a whole. Then first I find the fifth root of 32. Fifth root of 32 is 2. How do I find out? By factorizing 32. Let me factorize 32. The smallest number I take, 2. So 2 1s are 2, 2 6 are 12. So 2 16s are 32. So 2 8s are 16. Then 2 4s are 8. Then 2 2s are 4. And 2 1s are 2. So I stop it there, right? 2 1s are 2. So I stop it there. Now I see 1, 2, 3, 4, 5. So 2 5 times, right? So therefore I can write 32 as 2 raised to 5. So fifth root and 5 cancels, and what is left? 2 is left. So 2 raised to 2. So 2 raised to 2 is 4. So that is how I find this question, simplification, right? So 4 is my answer. Now next. Now the next question, 125 raised to minus 1 by 3. So as you can see, minus 1 shows that 25 will be, 25 will have 1 as the, let me show it to you. 125 will have 1 as its exponent, right? 3 shows that it will be inside a cube root, right? And this minus shows that it will be below 1, which is, it will be in the denominator. So this is what we get, right? So that is how you have to write, okay? First you have to look at each and every number, because every number, every sign that is in the exponent shows us and tells us something, right? So according to that you have to do it. So this 1 by cube root of 125, right? Now the next one is, what do you do? Cube root of 125. Cube root of 125, the method that I showed you before, you have to use that and you have to find. So it's 5 cube. Cube root of 125 is 5 cube, right? 125 can be written as 5 cube. So cube root and cube cancels itself. So cube root of 125 is 5, right? So 1 by 5. So this is your simplified answer, okay? So that is your answer. Now the same way you have to do 3 as a homework, so that you'll be able to learn from that homework, okay? Now next question, last question, third question. So first part, now look here, 2 raised to 2 by 3, 2 raised to 1 by 5. So you can see 2 and 2 are the same, both are in multiplication and they have different exponents. So you can use the formula that you studied earlier, a raised to m, a raised to n is equal to a raised to m plus n. So if you compare, here a is 2, right? You can compare and see, here a is 2 and m is, what is m? M is 2 by 3, and what is n? N is 1 by 5, right? So you can compare it, right? Now according to that you write a raised to m plus n. So 2 raised to 2 by 3 plus 1 by 5. Now 2 by 3 plus 1 by 5, how do you solve? Obviously you have to know this. You're not children anymore, right? You're not kids anymore. You know it. You have to use the normal method. So what is it? Cross multiplication, 5 2s are 10, or you can use the LCM method also. Any one method you have to use, right? So that is what I have used here. So 3 5s are 15, 5 2s are 10, 3 5s are 15, 5 2s are 10, and 3 1s are 3. So 10 plus 3 is 13 by 15. So if you do not know this, please look at your younger classes, okay? Please go back to your younger classes. Please study this method and all, because addition of fraction and all you have been studying from class 7. So you have to know all these things, right? Now if you do not know, please approach me and ask personally, okay? So now 2 raised to 2 by 3 plus 1 by 5. 2 by 3 plus 1 by 5, I get 13 by 15 when I solve it. So 2 raised to 13 by 15 is my answer, right? Now the next question. Now the next question is this. I have to simplify this. So simplification means what? Not making it more difficult, right? We have to make it the most simple form as possible. So what do I write? 1 by 3 raised to 3. I can write this as 3 raised to minus 3. Why? Because whenever I write minus, I know that whatever this number is going to be in the denominator. So 1 by 3 raised to 3 can be written as 3 raised to minus 3. Now 7 was already there, and we already know the formula, a raised to m, the whole raised to n. What is the formula? Is equal to a raised to m into n. a raised to mn, a raised to m into n, right? So multiplication. So that's the same thing we did here. A raised to m, the whole raised to m is a raised to m into n, right? So that way we get minus 3 into 7 is minus 21. So 3 raised to minus 21 is the solved simplest form, right? Next one. Next one is this. So last question. 11 raised to 1 by 2, 11 raised to 1 by 4. So you can see that this is 11, 11. Only the exponents are different. So I can use this method. A raised to m by a raised to n is a raised to m minus n, right? Comparing, you can see that a is 11, m is 1 by 2 and n is 1 by 4. So you substituted 11 a raised to m minus n. So 1 by 2 minus 1 by 4. So 1 by 2 minus 1 by 4. Again, this is in your lower classes. You have to learn how to solve this. So 1 by 2 minus 1 by 4. When you take the LCM or when you take the cross multiplication method and solve it, you get 2 by 8. 2 by 8 is clearly cutting it, you get 1 by 4. So simplest form, we have to write in the simplest form because it's simplification, right? So 11 raised to 1 by 4 is your simplified answer. Okay, so this is as simple as this, very simple part of the chapter. So you have to learn this. So now in the next class we'll be starting with a new chapter. So before that, I have told you that in the end of this video I'll be telling you some important things. So the main thing that I want to tell you is to follow these 4 steps. Okay, first study, first of all. Then you have to practice whatever you have studied. Then you have to keep revising whatever you have practiced, otherwise you'll forget it, right? No use of studying without practicing because you will not be able to retain it. No use of practicing without revising. One time practicing not enough, you'll forget it. So you have to keep revising the same thing and you have to repeat this process over and over. Why? Because without repetition, it's not going to be thorough. It's not going to become a habit. So you have to do that. Okay, so this method, this SPRR method is very important in mathematics and in any other subject. Okay, so you have to follow this method and you have to study. And towards the end of this chapter, this is the end of the chapter, so I want to tell you that whatever assignments, homeworks I've given you and notes of this chapter needs to be submitted to me on Monday. Okay, on Monday you have to submit it. I'll be giving you a message regarding this along with this video. So those who have watched this video will know it. Those who have watched the rest of the videos will know what are the assignments. So please make sure that you have done all the assignments, homework and notes. Okay, assignment should be on A4 size paper. Notes should be inside a notebook, particular notebook, and homework should be inside a separate notebook. Okay, so you have to maintain a homework notebook and a classwork notebook separately and you have to do it accordingly. Okay, so every homework I have marked myself and I need you to do every homework by yourself, because as soon as I look at the question itself, I'll know whether you did it or whether someone else did it. So according to that, your internal marks, I'll be marking it. Okay, and according to how much you submit. If you submit it early, you will get more marks. If you submit it late, not on time, then your marks will be cut. Okay, so make sure that you are following whatever I'm telling you. Okay, because discipline is the main thing, right? So make sure that you're disciplined enough to be doing what the teacher is telling you. All right, so now watch all these videos. We have around 7 to 8 videos from this chapter. So make sure that you have studied all these videos properly. You have watched this and you have studied it properly, and if you studied it properly and if you're following these 4 steps, then there's nothing that can stop you from scoring the best marks in mathematics. Okay, so make sure that you follow this step from the beginning till the end. Okay, and study this chapter well, and whatever doubts you have, you can always approach me in the school. Okay, and I've given you the time also, from morning 8 o'clock to evening 4 o'clock, 3 o'clock. You can always approach me. Okay, I'll be here in the campus itself. So study well. See you in the next video with the second chapter.